Now that you're familiar with the concepts of validity and reliability so that you can address the technical adequacy of the measurement tools that are used, I'm going to describe some data collection tools that get used a lot in educational research. I'm not going to describe everything that you can think of or that you will find, but I'm going to try to hit some that I've seen the most and seem to be used the most often. In the next two parts of this module, I want you to be able to describe different assessments of cognitive performance and describe assessments of non-cognitive performance or traits. So I'm going to be distinguishing between tools that are used for measuring facets of cognition and those that are non-cognitive. In other words, I'm going to talk first about tools that we traditionally use to measure all kinds of knowledge. So if you think of cognitive tools, think knowledge. And then I'll talk about some tools we use for measuring all kinds of non-knowledge types of traits or performance. So when we're making assessments about cognition or knowledge, we usually give a test. You're all very familiar with a variety of tests. Usually a test involves questions and the subjects have to answer them or do something based on the questions. We have tests for a myriad of things and they all seem to be part of the education culture that we live in. What distinguishes different tests are the reasons for using the test. They also differ on how they were developed, and then they differ on the psychometric properties. Remember, that's the reliability and the validity of the test and the use for the test. The test isn't valid, but its use can be valid. So you're already familiar with most forms of testing, so I'm going to focus on standardized tests. Some examples of these are the state-mandated CRTs, the SAT, the law school entrance exam, the GRE, all of these. We call them standardized because there are standardized procedures for giving the test, for scoring the test, and interpreting the results. So that's where the word standardized comes in. Very often, these tests are high stakes. And that means that important decisions are getting made with the results. Students may need to pass a test to graduate, such as the high school proficiency exams, or someone may need to reach a particular score to get accepted into a field of study or even a job. Usually, standardized tests are prepared commercially. They're developed by teams of writers following a framework that's designed ahead of time for the specifications of the items. So when you write these tests, when you're on these panels that write tests, you're given a list of specifications and asked to write a certain number of items that will get at a very specific objective or part of a standard. Then the questions typically go through a really rigorous review for bias, content validity, clarity, etc. I've served on writing teams and it's very difficult work. It's surprisingly hard to write good test questions that will pass a review process. I remember on one panel we had this huge discussion about whether it was fair to use an image of mashed potatoes because some children might think it was an image of grits. I don't even remember what in the world we were testing that we needed images like that, but I sure remember the argument that we had. From my discussion of reliability, you will recall how error can be introduced if the test is not administered according to the instructions. So the same applies to how it's scored and interpreted with standardized tests. You can't use a standardized test and then try to draw some inferences from it that have nothing to do with the test. That goes back to validity. Standardized tests can be scored by machine, but there are often standardized tests that have to be scored against a rubric by humans. When we humans are scoring a test, like for example a writing exam, remember that we have to make sure the scorers are looking for the same thing and scoring the same way. And we have to run those analyses of inter-rater reliability on standardized tests. There are two ways to approach the interpretation of scores from standardized tests. The interpretations are either for norm-referenced types of tools or criterion-referenced tools. So let me distinguish for you between those two. Norm-referenced interpretation means that we've given that test many times to similar groups of subjects and we've developed a curve of what to expect. We can then take each subject's score and compare it to where the scores in the norming group were. A person's scores are always interpreted by being compared to that norming group in a norm reference test. That is critical to understand. A child's score from a norm reference test shows their rank or their order, where they fall in that distribution of the norming group. For example, when we use the Stanford Binet IQ test, it has been normed on millions of subjects over many, many years. So we know that the average is 100, and then we have set deviations from that. And every time we give it, we're looking at where a person's score falls along that distribution. The SAT is normed also, so that the admissions office can look at a student's score and know where on the curve that person is with a lot of confidence. You will find discussions in the research articles of ranking mechanisms such as percentiles and quartiles. We're not going to go into that right now, but both apply. They're ways of labeling the different sections of that bell-shaped curve. With a norm reference test, there is always a curve, and you are always interpreting the scores by some kind of comparison or ranking. So I've given you some examples on this slide. You will see a phrase like Philip's score places him in the 95th percentile. It actually drives me nuts personally when they say Philip is in the 95th percentile. No, Philip is physically sitting in your classroom. Philip's score on that instrument is in the 95th percentile. Joan's score is in the bottom quartile, and you can see that wouldn't be as good for Joan. She's down in the lower part of that curve. When we are working with norm reference tools or tests, we often standardize the scores, and you will see them referred to as Z-scores. Don't confuse this with a standardized test. It doesn't mean that it's a score from a standardized test. It's actually a mathematical process that takes the raw score and changes it to a number that indicates where that score is in the whole distribution of scores. So imagine you're giving two tests, one in math and one in reading. Obviously, it's going to be difficult to equate a student's performance on the two tests. Maybe the score on the math test ranges from 0 to 500, and the scores on the reading test range from 100 to 300. You can't compare a child's score of 250 on the math test to a child's score of 250 on the reading test. So we transform or change each score into a standard score or a Z-score. This actually, it measures how far away or the deviations from the average or the top of that distribution curve. Then we can compare. So we can say that Sarah got a 450 on the math test and she's in the 95th percentile for math, while she got a 220 on the reading test is in the 60th percentile for math. Not her, but her score. So then when we read about Z-scores, the raw scores have been changed into a number that shows where along those percentiles the student's scores fall. Criterion referenced tests do not compare scores. Instead, there are benchmarks or standards or cut scores that are used for classifying the child's score. So they're usually based on the percent correct, and they sometimes can be as simple as pass and fail. There might be a line in the sand, and if you score 1 point over that line, you pass. If you score 1 point below it, you fail. That's a criterion referenced kind of tool. In the state of Nevada and most states, there are criterion reference tests for a variety of subjects and grades. These CRTs are scored, and then the scores of each child are compared to cut points. For example, we typically set cut points for classifying scores as approaching mastery of the standard, meeting the standard, exceeding the standard. And I've given you some examples on the slide here. Jeannie passed the Nevada High School Proficiency Exam, which is HSPE, you'll see it shortened that way, for English. Or Scott failed every final exam and is being considered for retention. That's a criterion referenced kind of judgment. 26% of Ms. Gerard's 4th grade class is in the meets standards classification for reading. So about a quarter of her kids are right smack there in the middle in the meets standard. And those phrases are always, they're talking about a cut score or a benchmark or an established line that the person has to be over for each category. Now, there are other tests of cognition and knowledge, and these are not, they are very, very common in educational research. We use aptitude tests, for example, which are often a combination of knowledge and skill and intelligence and motivation kind of all put together in this construct we call aptitude. And these are used to predict future performance or success. They're almost always commercially prepared and normed, although you can find some hilarious examples out there if you Google some aptitude tests. So if you take an aptitude test, for example, that puts you in a range for psychology, then your score that you get is actually being compared to a normed group of successful psychologists. And it's seeing how close your score is to the group that we know has been successful. Achievement tests are given all the time in education, so I'm not going to spend a lot of time on them. They're often made by teachers, and keep in mind the need for those psychometric tests for reliability and judgments of validity. If you're looking at research and you're finding that it was a researcher-created achievement test, you need to be really cautious unless they give you the psychometric information for reliability and validity. Alternative assessments in the world of educational research applies to authentic types of tools for making cognitive measurements. Don't get mixed up with the way that we in Nevada refer to alternative assessments for students with special needs. They're not the same thing. That's a Nevada term. In educational research, we're talking about performance-based tools, such as projects or actual performances or challenges. And these require multiple raters and a rubric. And similarly, we can gather information about what students know and understand by going through portfolios or collections of student work. And these are very authentic ways of gathering data about what kids know and can do. But they're not used as often for quantitative research because they require huge resources for coding and gathering the data and the observations and the inter-rater reliability that is needed. So you can imagine why, even though we know these could be really valuable tools for gathering data, they're much tougher to get the resources that you need to really pull them off well. Now I'm going to switch gears here and go into some non-cognitive measurement tools. In educational research, we often study much more than just knowledge or what a person knows. We want to know about the learner's motivation, beliefs, attitudes, perceptions about the teacher, the content or class, their self-perceptions of how much they think they know. These end up being fascinating traits that influence learning. We often need demographic information when we're doing studies, such as ethnicity, socioeconomic status, gender, age, etc. Those are not cognitive measures. So we need tools that measure these kinds of traits or characteristics. Let's say I'm studying different types of group work that could be used in a science classroom. One thing I may want to measure is the students' preferences for the different ways of working in groups. So I need to develop a survey or a questionnaire that gets at that kind of information. I'm not interested in that case about what they know, but about what they prefer. Obviously, these types of measures are harder to make reliable and valid. Imagine trying to measure something like boredom. What in the world is that composed of, and how do you reliably measure it? So it gets really interesting, but this is where some of the fun of the research can come. Obviously, there are some problems with non-cognitive measures. The researcher has to be really careful that the construct, such as boredom, is defined and measured properly. Think of constructs such as self-esteem or mood. Most of these measurements are gathered through survey questions rather than multiple choice with right or wrong answers. So there's a phenomenon known as the response set, and that means that there's a chance that the subject simply answers one way every time, like choosing all strongly agree on a survey, or with some kind of pattern. You'll see kids go strongly agree, agree, don't agree, strongly agree, don't agree, or agree, don't agree. And they make this pretty little picture on their survey. And that's always a chance when you're giving these kinds of measurements. It's always a chance when you're giving a cognition measurement too, but it also causes problems here. You'll remember that from my discussion of reliability that one way to measure whether this is happening would be to see if they answered similarly to similar questions. But then the tool gets very long and subjects can get irritated or simply fatigued. When subjects answer surveys, there's always error from a factor we call social desirability. I think the easiest way is with an example. Imagine that I'm actually researching racial tolerance in a group of people. When I get asked, or when a subject gets asked about their attitudes about diversity in the classroom, for example, they're likely to give answers that they think are more socially acceptable and may make them sound, even in this case, it's probably more socially acceptable to be tolerant of diversity. And so the subjects may be answering in a little bit more positive towards tolerance than what they really truly feel. And so that's always a chance of error in being introduced that way. One last problem is faking. You know those personality tests that you take, or one of those tests that assigns a color for your personality? Some folks, when they take those tests, they try to answer so that their profile will come out a specific way. Maybe I'm trying to impress my boss, and I want my boss to think that I'm a bubbly, people kind of person, so I'm going to try to answer the questions that way. And on a really good, reliable instrument such as the Briggs-Meyer, there's built-in ways to address that. It's nearly impossible to do. But even when they do that, it's still not going to really, truly represent their personality. And on these types of measurements, it's hard to measure reliability because there's no right or wrong answers. So you have to use the types of reliability measurements that look at how similar questions are answered. Because these non-cognitive measures often include variables, a whole bunch of variables that can make up a construct, you can have more confidence in the results of tools that are commercially prepared, that have been validated, and that have reliability metrics that go along with them. You will see personality inventories, another example. These are relatively stable over time. For example, there are assessments of how extroverted or introverted you are, and these seem to be pretty stable over our lifetimes. But you'll also find surveys for less stable traits or characteristics, such as your attitude towards pay for performance. that could change depending on how your evals are coming in for the work that you're doing. Or a student's preferences about doing homework could change even depending on the day of the week it is. I don't know about you, but I don't prefer to do homework on a Friday evening. So now in the next and final part of this lecture, I'm going to specifically discuss surveys and questionnaires, giving you some things to look about as you read research, because you're going to find those are used a lot in educational research.